Hey guys, so my presentation will be on HH2, which is on chromosome 8. The gene responsible for HH2 is FGFR1, which is a part of the FGFR family, in which they have highly conserved amino acid sequences and usually differ by ligand affinities and tissue distribution. FGFR1 specifically has an extracellular part that interacts with fibroblast growth factors, and those growth factors can be acidic or basic in nature. Once this interaction happens, a cascade of downstream signals will occur, which eventually influences things like mitogenesis, differentiation, and limb induction. Generally, mutations in this gene that lead to HH2 are loss of function mutations that can occur in the germline or somatically, and the mutations that occur are usually within the gene itself. In my specific article, they found de novo mutations or deletions, which kind of goes with the idea that they will be somatic, as well as in total they studied 4 familial cases, 8 sporadic cases, and 1 consanguineous case, which means that the parents were closely related, and they found that there was 1 nonsense mutation, 2 frame shift, 2 donor splice site mutations, and 8 missense mutations. Here you can pause to take a look at all of the mutations that they found, and I've put shapes by each type, and all of the mutations were consistent with the inheritance pattern of this disorder, which is autosomal dominant, because the researchers reported that all of these mutations were heterozygous except for A167S, and that was likely because that was the child of the consanguineous parent. You can also pause here to see which mutations were specifically found in the 4 families studied. In the specific example of Y99C, tyrosine is changed to cysteine, which is close to the cysteine at position 101, and research said that this would disrupt the disulfide bond in the Ig-like domain 1, which you can see in the figure indicated as Roman numeral 1. And then more generally, they said that there were 4 mutations as listed that affected the extracellular residues. And in the figure, you can see the transmembrane domain of the protein indicated in black. And then they also noted that 4 of the mutations would affect the intracellular residues, which they indicated in gray. In general, mutations in our protein of interest lead to impaired receptor signaling because ligand binding and the resulting dimerization and recruitment of intracellular signaling proteins is disrupted, and this will later go on to disrupt normal processes such as differentiation. And I also noted that FGFR1 guides GnRH neuronal migration, which has a big role to play in delayed sexual maturity. So this is another specific example of something that could get disrupted. In terms of animal models, this gene can be found in many different creatures, including amphibians and different types of mammals, but all of the studies that I looked at were specifically referencing mice, and these studies were able to look at a variety of symptoms that occurred, such as craniofacial defect, ossicle malformations, or just symptoms related to hearing in general, as well as organ development. In terms of treatment, doctors would mostly be looking to alleviate a patient's symptoms. So if the patient wanted secondary sex characteristics to appear, then they would give them increasing doses of injections with testosterone or HCG. And HCG is just an alternative to testosterone therapy for males. And then they could also inject females with estrogen and progestin. If the patient wanted to become fertile, they would have to use combined gonadotropin therapy. They could also use pulsative GnRH therapy, which just delivers the GnRH through a portable pump. If those methods were unsuccessful, doctors could also try in vitro fertilization. And then the other treatment mentioned was calcium and vitamin D intake, so that any decreases in bone mass could also be treated. I think some improvements on how this disease is treated could be found in current molecular research or doing more molecular research so that treatments can intervene this way. I say this because a lot of the other symptoms are things that would happen in development, such as hearing loss or cleft palate, the fusion of bones. So maybe one day, far into the future, CRISPR might be a type of editing software that could be used. And then an experimental treatment that I saw being done currently that I thought was interesting is with kisspeptin, which is a naturally occurring hormone in our bodies that tell us to produce other reproductive hormones. They noted that a continued amount of this can can have the opposite effect on a person so that the body stops making hormones needed for reproduction. So what they're doing is giving people 24-hour infusion of kisspeptin to explore its role in the body in reproduction. And this study is expected to come to a close in 2023.